Hey guys, welcome to another Physics Kids production. I'm Mackenzie and I'll be walking you through magnetism, what it's all about. First of all, what is magnetism? Magnetism refers to physical arising from the force caused by magnets. These are objects that produce fields that attract or repel one another. When magnets repel or attract, the rule to remember is that opposites attract. Every magnet has both a north and a south pole. When you place the north pole of one magnet near the south pole of another magnet, they are attracted to one another. When you place like poles of two magnets near each other, north to north or south to south, they will repel one another. Attraction means that the poles are pulling towards each other, while repelling is when the poles are pushing away from each other. A permanent magnet is used to show the attraction and repulsion easily because of its opposite poles on each end of the magnet. A permanent magnet is an object that produces a magnetic field around itself. It is this field that enables them to stick to each other and to some types of metal. Specifically, they stick to ferromagnetic materials like iron and things that contain iron, such as steel. Magnets are pretty mighty, but what happens when you break a magnet? If you were to break a bar magnet in half, you will end up with two bar magnets. The trick is that the break does not change the alignment or magnetic orientation of the atoms or molecules. So if you had a long bar magnet and slice it up in 10 or even more pieces, each piece would have a north and south pole. But what might happen if a magnet is heated? When a magnet is heated, the high temperature increases the kinetic energy of its atoms, causing the loss of the magnet's alignment. However, its magnetism can be reestablished through the use of a permanent magnet or a solenoid. A solenoid is a cylindrical coil of wire acting as a magnet when carrying electric current. Magnets have magnetic fields that are produced by electric currents, which can be macroscopic currents in wires or microscopic currents associated with electrons in atomic orbit. The Earth, in fact, is an example of a huge magnetic field. Because the core of our planet is filled with molten iron, there is a large field that protects the Earth from space radiation and particles such as the solar wind. When you look at tiny magnets, they are working in a similar way. The magnet has a field around it. The magnetic field is represented by magnetic field lines, which show the direction of the field at different points. Alright, and that's a wrap on magnetism. Thanks for watching.